friend, Sam Partee. Sam, over to you.
Roger, always nice to be at another Data Science Central conference. Today we have an absolute panel of heavyweights, people that are on the ground floor of building agents, people that have experience actually doing this themselves, have large followings on social media. This is a group that will tell you exactly how, when, where, why to do exactly what you want to do with agents. Today we have Kartik, Victor, and Hamza, all three of which are exactly as described. I will quickly introduce myself and then allow each of them about a minute to introduce themselves as well. But mostly, I'm going to do my best to shut up and give them the chance to just fill this panel with their insight and expertise. So I'm Sam Partee. I'm the CTO and co-founder of Arcade.dev. And without further ado, Hamza, why don't you start us off?
Hi everyone. First off, thank you for having me, Sam and Raja. Great to meet you again. My name is Hamza. I am a founder of a company called Traversaal.ai. We build data science agents, and we also work with enterprise knowledge management. I also teach with SPD at Stanford, and I'm also an adjunct at UCLA.
Victor?
Hey everyone, hopefully you can hear me. My name is Victor. I'm a research software engineer at Microsoft Research. And essentially my connection to Agent is that about 2.5 years ago, there's a group of us who were sort of excited about exploring new ways of building software. And one way we sort of explored that was that as opposed to the developer explicitly building a set of steps, which might include LLMs to solve a problem. How about we define the set of agents, give them some tools, and sort of let them explore any arbitrary problem space by exchanging messages. And so all that work sort of culminated in AutoGen, which is an open source framework with built-in multi-agent applications. And the space has come really far over the last 2 years, frankly. We've learned a lot. Fun fact, we've rewritten AutoGen twice, completely different architectures, and I feel like we're still all learning. And a lot of that has, there's also been some standardization around like all we've learned as seen in some of the products we have at Microsoft. So there's Azure Foundry agents, Copilot Studio agents, that sort of thing. So
I now have to ask about why you rewrote it twice. So that's coming back up later, I guarantee it. Kartik, why don't you go ahead?
Yeah, sure. Thanks, Sam. And thank you, for the invite to be on this panel, Raja. So I'm Kartik. I'm currently head of AI at Wand AI. At Wand, we're basically building tools for workforce automation and for workforce autonomy in order to basically support the hybrid workforces of the future, which I think are no longer of the future. I think we're seeing them already with, everybody using agents in their everyday tasks, whether it is coding, whether it is technical support, whether it is sales and go to market. We just had a fantastic demo put on by one of our GTM directors today, where he created essentially an entire app over the weekend, in order to help him with his selling. So yeah, there's a lot of interesting things in that space. Before coming to Wand, I spent some time working on a lot of planning, reasoning, conversation, workflow automation, and so on at IBM. In fact, Victor and I go back a long way. We were part of the same team at IBM.
Oh, look at that. That's
Yeah,
amazing.
yeah. So yeah. And since then, I've also been in the world of startups a little bit. Essentially, during this time of great acceleration in AI, and specifically based on LLMs and the agentic paradigm and so on, it's a great time to be putting in effort in this space. I think there are great payoffs to be had, and there's also a lot of great research to be done, a lot of learning, as Victor says, to be done. So yeah, I'm looking forward to the panel. Very excited about it.
I mean, you can tell already that everybody on this panel has a ton to say, and I'm very excited. We have to start off. I think there was an email thread before this panel about, well, maybe we should start with what actually is an agent first and ground it. And I think that was a very good call out. I think sometimes we in this field just jump immediately to what's cool, what's in the latest research paper, And it does help to ground a lot of these conversations. I often have a little bit of a spicy take on what an actual agent is because I'm hyper focused on tools. But I'm going to say now, Victor, why don't you start us off and give us your definition of what you think an agent is? We can't hear you. You're on mute. You're on mute. You're on mute.
Yeah, so sorry about that. Yeah, gets me every time. So about a year and a half ago, or about a year ago, I started to write a little book around like, hey, no, how do I help people navigate the whole multi-agent space? And at the time, I defined an agent as an entity that can sort of take a task, reason over it, is able to act, and then can communicate with other agents or humans, let's say get feedback, request handoffs, and then it can adapt. So adaptation here means like it can take into consideration the state of the task, maybe previous experience, and then solve the task.
Are handoffs part of the minimal required set of the definition of agents, though?
So handoffs in my original definition, no, but the ability to act here is tools, and most of the time,
Agency.
tools are driven by handoffs. Or I don't know, handoffs drive tools, or handoffs are implemented by tools.
What's a
But
handoff? Define that for people.
Yes, so that was an agent. So the next thing above an agent is a multi-agent system. So essentially, you have a set of independent agents. They have their own configurations. A task comes in, there's some sort of decomposition of the task, say assignment of capabilities or assignment of sub parts of the problem. And the process of flow control between one agent or one entity and another, typically we might think of that as a handoff. And so I guess, Sam, in your context, the process of an agent sort of arriving at the conclusion that like a part of the subproblem is complete, and there are a set of other entities that might be capable of completing the rest of the problem. So the process of constructing that, clear control flow transition, we can think of that as a handoff. So just to reiterate, an agent is an entity that can reason, act via tools, adapt via memory, and then communicate with other agents or human beings. And that's usually a starting point. Over the last few years, it's gotten a bit simpler for me, and as just anything that can address a task on behalf of a human. And I might talk about later why I am arriving at that more simplified version. But if you wanted to be,
I'm already excited.
reason,
I
act,
think
adapt,
key
communicate.
point being act, right? It's
Yeah.
agency. An agent is not an agent unless it has agency. That's kind of the whole point, right? I say this all the time, like, tool runtime, where you run a tool is now an exercise for the developer. It's something that MCP tried to address, right? Is that it's now part of the agent loop to say, oh, I need to go and run this particular deterministic, possibly piece of code on behalf of this agent so that it can act in the real world, right? That is a very important piece that I feel like about a year ago we kind of just left out, more or less, I'll say. Kartik, Hamza, additions, subtractions, thoughts?
Yeah, I think one thing that I think it's a great definition by Victor. I actually want to go back a little bit to, the early days of AI, right? Because again, it may feel to a lot of people like, oh, agents, this new thing that we're talking about. Agents are one of the very first things that, when AI as a field kind of started in the 50s, right? Agents were one of the first things to be defined, right? And every time I hear agents, this is
In
actually
the
useful.
50s, like Alan Turing, 1950, computing
Yes,
machinery and
yes.
artificial
I'm
I
literally
love you
talking about
already. That's
I'm
great.
literally talking about 1956, the Dartmouth workshop, which was where they termed, they kind of the field of artificial intelligence was born, right? And again, agents were one of the first, I guess, in today's parlance, motivating use cases of AI, right? So this is very useful for me. I'm going to put it out there, for other folks as well. Every time I hear agent, I think of this very simplistic picture from the sort of the Bible of AI, right? The Russell and Norvig textbook, the, artificial intelligence, a modern approach, the green book with the Berkeley Campanile on top of it and so on. It's very simple. There is a world, right? You draw a square box. There's a world where things are happening, right? And you have an agent beside that world, right? And there are two arrows, one going from the world to the agent and one going from the agent to the world, right? So the arrow going from the world to the agent is where the agent is observing, right? So there are observations coming in from the world, right? How does the agent do this? Via sensors, right? You have to have sensors so you kind of understand what is going on in the world and get all the information and so on. And similarly, there's another arrow going back from the agent to the world, right? And those are actions, right? How do you act in this world, right? And how do you actually, execute these actions? Effectors, basically, right? So today, when we talk about tools, the tools are nothing but the superset of all of these sensors and, actuators or effectors put together, right? And the agent is nothing but the brain of the agent. It's taking all this information that's coming in from the world, it's processing that information, and then it's deciding what's the best next step to take, right? And I think, to me, I always find myself going back to that kind of definition, because that is kind of the simplest definition on which you can layer all of the innovations of today, like tools, like agentic frameworks and so on and so forth. You can add multiple agents into the system, how they interact and so on. In fact, I think there were a few questions in the chat also about how are agents different from microservices, right? They don't have to be, right? But they are, in the fact that agents can think for themselves, right? You don't have to write all of the deterministic code, telling the agent what it needs to do. That's where the power of LLMs comes in and so on, right?
I thought my definition was simple, and here you are with two entities in the diagram.
Right. No, again, like I said, I find it useful because for me, this is the canonical definition of an agent, right? And everything we add on top of it neatly slots into that, and we kind of build. It's like an onion, right? You have the simplest layer in the middle, and then you build these other layers of complexity on top to help you address the complexity of the use case that you work with and so on. But yeah, that's really where I would go.
There's an interesting kind of comparison to reinforcement learning there, where you're talking about interaction with an environment. I want to come back to that later, but yeah. That's very interesting. Hamza, anything on that you want to add?
I think I'm going to be the other spectrum of the conversation.
Oh, here we go.
Think of agents as bad interns. Let's just start with that, right? I think so. My job is to help people understand, like explain like I'm five, right? So I start with, okay, what are agents? Think of agents as bad interns. Their job is to go to different people, which we call tools, to get a job done. And sometimes they forget. Sometimes they hallucinate. Sometimes, you say, first you have to go to the finance department, then you have to go to the marketing department, and then you have to go to the HR department. And what they end up doing is going to the HR department first and then to the finance. So, and sometimes they do it the right way. So, reiterating, agents are LLMs with access to many tools. LLMs are what is our bad intern, who has been tasked and been described in a simple prompt or complex prompt to go to a certain tool to get a job done. And once
you're like covering my mouth, like don't ask a question, stop talking.
Right. And then when the job comes back, when the job gets done, it is to move it to the next process. Right. And that's how I start describing agents to people, because there are so many complicated definitions of it. I try to simplify it, humanize the experience.
So, okay, wait, here's another point. All of you have brought up this subtly in what you've defined, which is this trade-off between determinism and non-determinism.
Yes.
Like generality that's introduced, right, on purpose now. If you think about it, we snuffed this out over decades with tests and CI in software. We've tried to eliminate non-determinism purposefully, and now we are purposefully introducing it because of its ability to generalize, right? Which is, the LLM aspect of the program. The tuning knob, if you will, of agents, whether it's like a declarative graph gives you, more determinism. And Hamza, you were describing, right? Go to this department, go to this department, go to this department. And that sounds like a declarative graph. And Victor, you were talking about autogen, right? And how you rewrote it twice. So I want to talk about frameworks, their approaches. If you look at something like OpenAI agents, if you look at something like LangGraph, if you look at something like across the board, there's a lot of different approaches. Autogen, another different approach, right? Or even semantic kernel, another one out of Microsoft. They're all very different. And so I'm curious to get your opinions on what's working, when is it working, why are they using it, and how does it affect that knob, that tuning between determinism and non-determinism?
Can I go first? Sorry.
Go ahead. Yeah.
Again, I'm sorry, I'm going to set the precedent. I am highly against generalized agents. And one of the things that we literally fight with companies, or you fight with people, is to say, build an agent that does one job, which we call the vertical agents. Focus on getting one job done correct, so that you reduce the points of failures. Because when you have an agent or an LLM is 95%, let's say 95% accurate. If you have 30 points of interaction, you have 30 points of failures. The probability of failures go really, really high. So my argument, or what I tell people, is in order to make it deterministic, is to reduce the number of things that you expect an agent to do for you, and focus on very highly personalized example or implementation. For example, this was my resume agent. It will only find me resumes. It will not collaborate with something else, with finance department, and get the budget for it. But this resume agent
Connected to a higher level agent system, or is it like a specialized agent? I'm playing dumb a little bit, but like
specialized agent that does, like, there's an HR agency. Within HR agency, we recommend having 5 different agents that do one separate jobs for each one of them. Again, for example, if you have onboarding for an employee, a separate agent should handle that. Similarly, if you have, you need to find the right people for a given job description, you should have a separate agent that does that for you.
I heard this said one time as a grocery store, right? You have somebody checking it out and somebody bagging the groceries. It's like
Exactly.
a separate job, right? And so those are 2 distinct agents. They're working towards the same goal,
Yeah.
but they're 2 distinct agents. Is
And
that
that's
kind
what
of
we've
what you're
been
talking about?
exactly, because that's what we do with microservices also, right? We basically expand our architecture, modularize and microservice architecture. That's what we've been doing, so that if something breaks, right, we can fix that exact part, rather than building, vibe coding our way through 2,000 lines of code into one function that has every single thing that's ever happened since sliced bread.
I mean, it makes a lot of sense. It's the least, responsibility principle, right? It's the same principle we've seen. Victor, I do want to come to you and say, please talk a little bit about what you just threw in there with why you rewrote AutoGen twice, because I'm very curious myself. Building off that and also talking about that handoffs, like the, grocery store example, and also what Hamza said, add your point there.
Yeah. So first of all, I want to agree with Hamza. If your business has a specific function that you care about, you don't need a generalist multi-agent system. And most of the time when I give talks, I start out with this big circle with a small circle inside. And the big circle is like all the things that IT teams or software developers need to accomplish. And the small circle is the things where a truly autonomous or generalist kind of system really gets you ahead. Now, for every other thing, the key is to know what is the right tool for the job, right? If you have just one thing, you build a workflow. And so a workflow is pretty much what Hamza described. There's a bunch of steps. Each of the steps might benefit from some type of expertise on LLM. You code that in there. You know the exact solution to the problem. You sort of codify that. And that's your software. Now, why might people be interested in that small bit? So I try to describe that as complex tasks. And so what type of task is more amenable to this sort of generalist, leveraging the reasoning capabilities of an LLM just in time to solve the problem? And so it's things like, does the task touch multiple systems? So things like back office kind of tasks. We have emails. These emails need to be extracted. They might have attachments in arbitrary format. Just the kind of thing where you need to reason through the problem. And up until now, we didn't have ways to build software for systems like that. And many people just don't have problems like that. So it's essentially taking out time to localize that. So the first distinction I want to make is workflows versus truly autonomous kind of generalist systems, and know when to make the choice. And with AutoGen, we sort of started more with the autonomous exploratory kind of thing. And I think that is interesting in its own way, because with that sort of software approach, there are like several high-level benefits. So the first is like you could design one system that does many, many different things. If you have a platform, this is interesting to you. So essentially, you might have heard people talk about the concept of the everything app. And this can be very disruptive and can have a lot of market value. Number two, you save people a lot of time. And so the core idea is like if you truly, going back to Hamza's analogy of an intern who's not excellent,
Bad intern, a bad
A
intern.
bad intern, yeah.
a bad intern. Oh, well, I mean, okay, an intern anyway. An intern is still essentially they're this type of person that can do all this sort of back office kind of thing. The work they do might not require a lot of skill, but it takes a lot of time. Also important. And so if you can get a system that can do that, you save a lot of time. And then finally, I think there's a final concept that I feel a lot of people miss out on is the promise of a overall self-improving system. So stick with me here.
Uh-oh.
Yeah, stick with me here. Imagine that you could build this sort of general system and the performance, you could measure it anyways, let's say 50%. And in about a month, you measured the same system, you made no change, and now the performance is at 80%. So all that has happened is that the underlying models just got better at agentic orchestration, they got better at tool use, they got better at exploring the most efficient path to solving a problem in a generalized manner. And you didn't have to do anything. Like all the folks pouring all that money into the model, they did all that work, but your system just got better. And so those are like three things that make this sort of autonomous approach kind of work well. So I'll kind of stop there. So workflow versus like multi-agent, automated multi-agent like exploration. We need to know when to use what. Maybe today the workflows work really well. We can measure them well. We can evaluate each tiny component, and maybe that's where we go. But maybe the future would be like, and for a specific class of problems would be the multi-agent space. I really want to hear what Kartik has to say though, because
yeah, I was about to say, I know Kartik has something to say here. I want to interject really quick and say, like, it sounds like I don't know who's read the Go Explore paper, but they were playing like Atari games essentially. It's an RL paper. And the exploitation versus exploration and how you're talking about this and the trade-offs between them. And again, it's kind of like that tuning knot. There's a really interesting aspect of that I think we could dive deeper into, but I want to give Kartik a chance to talk about it.
Yeah, no, I think what I'll do is I'll maybe give it more of a enterprise POV in some sense, right? So I'm overcompensating for going research heavy in my first answer, right? And building a little bit, I think, on what Hamza and Victor were saying as well, right? So one of the problems that we have noticed, when we take these to clients, especially enterprise clients, right, is, and it kind of breaks down into three things that I'll try to, break it down into. First, and I really should not be saying this, so please don't quote me or record me on this, right? Not everyone needs agents, right? Like, let me just put it out there, right? I know we're all trying to, sell things, we're trying to build companies, we're trying to build these things, but let's also be sort of intellectually honest for a moment, right? There are lots of great tasks today. And again, this is going back to Hamza's point of narrow, agents and so on. Sometimes a narrow agent is a piece of code. It's a script, right?
Yep.
You don't need anything more complicated than that. If
Even
that's
25 beats RAG a lot of the time.
Right. And if that's been working for you, then
yeah,
please resist the FOMO of going to an agentic system, because you are just opening up a world of pain, right? But that's one part. So I'll say that just as on the outset, that I think we're all aware of that, and I think it's important to acknowledge that a little bit, right? Yeah. The second thing, which is actually something that we've been working on a lot over the last 6 to 8 months, right? And in fact, as part of that is where we've had the pleasure of working with AutoGen, with Victor's tool and what his team is building out, but a lot of other frameworks as well, AG2, Llama Index, Crew AI, all of these other things, and we've been building our own internal framework as well. Is when you do have a relatively complex task, right? What you then need to do is, again, agreeing with what Hamza was saying, that I think generalist agents are not the way to go, right? Instead, what you want to do is now split a complicated task into multiple agents, right? Multiple specialized agents. Now, how do you do that split, right? So one of the ways of doing that split is you can have, I guess, what we call internally a project manager agent, right? So this is an agent whose role is basically to take a complex problem and break it down into a multi-agent assignment problem, right? And so as part of the project manager, that's something I think, Sam, that we can also discuss in the panel, what are all the, first of all, you need to do the breakdown. Second, you need to do the assignment to specific agents, right? So which, the role-based assignment to the actual task, right? Third, you need to do the planning task, right? Which is you need to plan out an actual sequence saying that, this goes first, then this goes next, and so on and so forth, right? And then you need to do kind of whatever you want to call it, either the self-criticism or the reflection or the replanning, or different terms for everything. Because a lot of these things, again, remember that you're interacting with real world data, and the real world is anything but predictable, right? So you want to have an ability to replan and so on. Okay. So
that's a really interesting point, though, is the real world data. I just want to harp on that really quickly. Is
absolutely,
that
yes,
it totally changes the replanning and the
exactly,
readdressing the query step is when you're actually addressing like a user's Google Docs. Obviously, this is something we're running into at Arcade.dev, is like we now have the user's data, right? Because we can progressively go get that. And that completely changes the replanning step, being able to access these real world systems. And so that's a very interesting point.
And in fact, there's a nuance there, which I think is obvious to you, but I think we should mention it, right? Which is all of this real world data is runtime data. It's not data that you have access to beforehand, right? So you cannot fine tune a model or fine tune an agent with it. You have to react on the fly.
Or an embedding model for a vector database. Like it's
exactly
not fine tuning that. You're not embedding this all into a vector database. You're going and getting that Google Doc at runtime.
Exactly. And so I'll end with this last thing. So there is this project manager paradigm, but that is still a very interaction heavy paradigm, meaning that you still need to expose the decisions of the project manager to the human in the loop, right? And you need to keep them informed of, here is how I'm breaking down the task, here is how I'm executing it, here is how I'm replanning and so on. Okay. And then now there's a third paradigm, which is increasingly, I think gaining a lot of adoption, which we are also supporting, which is kind of this full autonomy model, right? Which is basically if you have a human who comes in and says, look, I want you to build a department for this particular process, right? I don't care about being informed of all of the nitty-gritty of what happens in the department. I just care about the output. I just care about, the end result of things, right?
I've heard this called ambient agents or like background agents.
Right, things that are running in the background, and producing.
Quad code is an example, or like
exactly.
the box that Langchain put out.
Exactly. And in fact, the perfect example of this, again, like I said, don't quote me to my CEO.
It is recorded, by the way. So
I know.
Every time you say that, I'm like, oh my God.
I know. I'll make sure that, the audience that's not supposed to hear this doesn't hear it. But for example, CEOs are the perfect audience for this, right? Where basically CEOs will come in and say, I want to build this app, go away for 24 hours. Don't bug me, right? I'll give you the resources you want. I'll give you all the definition you want, and then come back to me with the output, right? And so that's kind of the third thing where you have a very complex task and you want now an army of agents that are breaking it down for you and producing something that is in line with your expectations, right? So these three things, just to recap very quickly, and then I'll pass it on, right? One, maybe you don't need agents at all. Two, if you do need agents for a complex task, maybe you need something like a project manager where you can use that as an interface, right? And three, maybe you don't actually need, again, any interface. You just have an army of agents going ahead and producing whatever you want. These are the paradigms we're seeing, more or less.
I have so many questions myself. I imagine the audience is now just peppering us with questions, but I can't even see the QA right now. I so many questions, but the one that's on the top of my mind is you kept saying project manager. And I'm curious, in these multi-agent systems, Victor, Hamza, have you experienced that the personification, like the giving it a role aspect or like supervisor role type agent, multi-agent system, has that been effective in like the planning and reasoning steps for a multi-agent system to solve tasks or arbitrary tasks?
In my experience, we need to have one. We absolutely have to have an independent one, unequivocally.
What does it do? What does it do? I mean, I'm playing dumb again, but like
it just do LLM as a judge. So for instance,
doesn't that compound errors though?
Yes and no, because what you do is that if you have a compound error, so let's say it hallucinates. So what is an agent? Agent, your LLM is given a JSON output for you, right? The JSON output is basically a tool that you will call to, right? What we're trying to do is that the act, reason, the action that you have to take, the reason that you're taking that action, right? And the some instruction that you need to pass to that tool. Those are these three outputs that we expect from an LLM, right? That is the first part. The tool activates, the tool gives you back a result. The AutoGen team, Victor, I'm going to say this, have done such a great job in having LLM as a judge because it works independently and it has a prompt that says your job is to see if this is done correctly.
What does that prompt look like for the audience? Like I've written a few of them, but like what are the key components of an LLM as a judge prompt for that kind of reasoning?
You are an LLM judge. You will be provided with output from tools A, B, C, D, E, F, G.
Yep.
This is the expected outcome. Please provide with a yes or no or a reason in JSON format. Please provide it in JSON format.
Please, JSON.
I think 4.0 has become pretty good in that. But please provide us the feedback in this loop so that we can evaluate. So if you're generating an image of a dog standing in, standing on Mars, right? We need that image to be generated correctly. But real human interaction. A lot of companies are implementing voice AI for taking orders. IHOP is implementing, right? If you say, hey, I want 16,000 pancakes, the LLM as a judge, eventually you'll have human in the loop also, but the
There's
LLM,
got to be a human at some point that goes, that's not a real order.
yeah. What we do in data science agents is that we look at an output that has been generated from a forecasting model, and we say, does this sound right to you?
That
And
makes sense.
sorry, go ahead.
Oh, it makes sense. It is the counterpart. I think the interesting part to me is like when you involve tool use is something that I've obviously, dove, headfirst into, is that it changes the LLM as a judge step because the data you can get back is very diverse.
Yeah.
And so it's not as simple as you're judging what the LLM is output. It is not a LLM generated piece of text necessarily. It could be a large quantity of, documents from Google, or it could be, your Confluence or Jira or what have you. And all of it, I mean, you think about it, there could be a prompt inside of one of those documents, right? And so this has been a really interesting challenge as we've connected to more and more systems. I'm curious, talking about tool use in general, with this reasoning and planning, has there been any challenges like that you've seen with tool use or any tools in general as things like MCP have come about, that you've seen in particular that are interesting and noteworthy for the audience? Anybody? Anybody? Grab the baton.
Yeah, so I think one thing I will say there is there's a lot of not existing, let me say, there's a lot of pre-LLM theory and applications, right? Especially from the field of, again, this is a plug because this is the field that I come from, planning and reasoning and sequential decision making, right? There is a very rich history of work over there that basically deals with exactly these problems, right? Which is, how do you create a plan? How do you, replan effectively? How do you create kind of these structures so that your overall execution is going to follow a particular guaranteed path in some sense, right? The thing that's new now is we are replacing the more or less deterministic insides of the brains of these agents, right? Now with something that is quote unquote non-deterministic, right? I say quote unquote because ultimately it is also running off of a probability distribution and all of that. It's not really non-deterministic, right? We just don't have the compute and the scale to make it deterministic in some sense, right? And in fact, that is the reason that we use LLMs as the basis for a lot of these agentic systems, right?
I appreciate you for explaining it like that.
But in my opinion, there are two ways to go about this, right? One is we can actually take, we can reuse some of the more deterministic structures, borrow from planning and reasoning and scheduling and sequential decision making, right? I'll post a couple of examples of papers, that did this, in the pre-LLM era. And we can kind of constrain, whether it's MCP, whether it's A2A, whatever, that's more of the implementation of the tooling stack and all of that, right? But you can kind of think of it almost as today, everybody knows about the concept of guardrails, right? But in the concept of something like RAG, right? So the guardrails are ensuring that the content, the text content that your model is putting out or that your RAG chain is putting out is conformant to a specific set of constraints or whatever, right? So I want us to think almost of guardrails, but for reasoning, for agentic chains in some sense, right? So what we're essentially saying then is, yes, I know that there will be uncertainty in the output, but I will quantify that uncertainty. And I will say that, okay, whatever plan this multi-agent system comes up with will be within this particular, execution, will be within this particular.
How do you do UQ, like uncertainty quantification, in this way with such a unfathomably large space of possible outputs?
Correct. So I think that goes back to the point Hamza was also making about kind of this error propagation, and the more complexity you add on, the more unchecked error gets propagated and so on. I think the way to do that again is to kind of isolate agents and tools into these, so if you think of a plan and you say that each plan has a slot for an agent or a slot for a tool, right? And then you kind of wrap that around with these, like I said, the reasoning guardrails in some sense, right? Saying that this agent's outputs can be within this distribution, but not outside of it, right? And if it falls outside of this distribution, then we kind of replan essentially, right? That's really how I would
We have
quantify.
5 minutes left, unfortunately.
Yeah.
I just realized sorry to cut you off. We have not done any question and answer. We went way too long. This was a fantastic discussion, though. Let's do a quick Q&A. We can do a few of them. There are 83 questions, 84, 85. Wow. All right. Anybody have a particular one that they're interested in? Because we are not going to get to these. I would appreciate it if anybody stuck around and tried to answer these with me. Whew. Let's do.
So Sam, I have been looking at the questions. I mean, do you need any help?
Yeah, that would be wonderful, Raja. I have not looked at any of these.
So I think one of the consistent themes here that I asked, and I think rightly so, one of the questions that people are asking is, well, how is an agent different from agentic AI? And does agentic AI still use Gen AI and AI or not, right? So I think that's probably something in that realm. And then one more thing, somewhat similar, how is it different from RPA? So I think that's a few different questions.
I'll touch on
putting them together.
this latter half. RPA essentially has no, or it should not essentially have any non-deterministic element to it. There should not be an uncertain piece of that program. When you call, process automation, when you call that process, it should run that process if it's a good RPA system. In this case, you are having a large language model control when and where that process is called and which process to call. And so that is an uncertain process that's actually saying which one to call, and actually how that process is called is also controlled by the LLM. So that would be the difference. The first part, I would say anybody jump in on.
So I think I'll take a very quick shot on that. We want to think them as complementary, not as opposed to or replacement of each other. So the way we build, and maybe it's just one way of building it, right? 5 plus 4 is 9, 6 plus 3 is 9, 10 minus 1 is also 9. So the idea we try to drive is we use an agent to call an agentic RAG. So our agentic RAG is built on the architecture that, there's a question that comes and it, sort of comes up with its own idea of how to approach and find the answer. The agent's responsibility is to call the agentic RAG tool. So this is my definition of, separating the two entities. If the agentic RAG fails, it's on the agentic RAG and we need to fix that. But they're not compounded in a way with each other. They're not fused in with each other. They're just in two independent entities. And we have seen the maximum benefit come out of it because I can make my agentic RAG really complex. I can build my routers. I can build my semantic search and, all sorts of interesting things within that. I could do query expansion. That intent, right? Hide, we use hide. So all of those things are set within the agentic RAG. Who's providing an answer to an agent and says, hey, can you tell me what is the difference between the revenues of Uber and Lyft across the past 2 years? That's a complicated question. The agentic RAG's job is to break it down into atomic units and then find the answer for you and then return back the whole answer rather than the agent saying, oh my God, I have to do every single thing myself and then break it down and go and fetch the answer.
I'm laughing also because I've seen a lot of people abstract tools up towards the agent. So like that question becomes not as difficult if you have a tool named like get stock summary for, X company, right? And the arguments are something string based that are easy to, discern for an LLM. And so like as we've seen people build more and more intelligent tools, going up after MCP a little bit, the agent's job has been reduced in its let's say complexity and responsibility to some degree to the point where it's more like what you're saying, which is I need to just delegate, right, into a new group that is specifically purpose driven towards this goal, which is kind of in line with what you said earlier. The vertical specific do your job kind of agents.
It's an interesting, I'm sorry, taking more time. It's interesting the demo are everywhere. Everybody shows a demo, at least in
Get
data
weather.
science, in the previous world, in our previous lives of being a data scientist. Kartik, I think you were too a data scientist at some point. We used to have accuracy. We used to have F1. We used to have
R-squared.
instant recall, hard-coded benchmarking on how good my model is. Now we say, hey,
Looks good.
I scripted out, I OCR a 10K document, one page. It's gonna work now. Give me $10 million. I call BS to that. I just basically say, you know what? The real world and the demo world are completely different.
Absolutely. Absolutely. One of the first things I focused on was evals for tool calling and trying to make sure that in my CI every night I could tell what the model changes did to my tool calling system. Because, back then they didn't have dates on the models like they do now, right? They just released a new, GPT 3.5 Turbo, and it would completely change the tool calling system.
Yep.
Now they luckily at least have dates. Let's do one more. We have probably a little bit of time.
So I see an interesting question. How do you
Go ahead.
handle error recovery and
What
error
was it?
handling and recovery in multi-agent systems that
Ooh.
work asynchronously?
That is a very good question.
Yeah, so so there's several ways to do that. It depends on how you architect your system. So if you're in the workflow domain where as a developer, you already know the solution to the problem and you've expressed that as a bunch of steps in your pipeline, it's a bit easier to do that because you can essentially unit test every single component. You can get a good sense of where things are failing. You can benchmark that at scale. Ideally, everyone should have eval-driven development where you have a dashboard and you can see how things are going. So that's a good way to think about it. Don't abandon any of the software engineering principles we've built out so far. So eval-driven development,
Yes, Victor.
unit testing as much as your stuff. Create a dashboard, and sometimes you should start out with a baseline that might not be agentic, script like Kartik said, and then you have a version that is increasingly more complex, and then you can go back to your investors and say like, the reason why we have this complex version is because it objectively does better than the initial version. So that's really where you should start out with. Because we have LLMs and agents, it means nothing. It doesn't mean we abandon everything we know about how we build software systems. So
Nobody wants to create that first version, though. They all want to jump to the second version. But
and it's inescapable. It's inescapable. You really should not think you can make any kind of meaningful progress without building your evaluation stack. You can't. You just can't. Anybody who's telling you differently
without handwritten evals.
Yeah, anybody who's telling you differently, should talk to Hamza. So that's the first thing. The second thing is if we're in the multi-agent domain, and I always talk about the fact that I'm a researcher and I spend a lot of my time thinking about what the future of these systems could look like. So today, autonomous multi-agent systems still have a lot of issues, error propagation, error accumulation, all that. I feel all those things will get solved. They're just not the way to do it today. But if you're going to implement a multi-agent system today, if you looked at a paper we released sometime last year, a paper called Magentic 1, which was a multi-agent configuration where, a complex task comes in, there's actually a module that does like explicit planning. It says, okay, here's the problem. We're going to break it down to a set of steps. We're going to assign each of these steps to one of several agents. And as each agent takes an action, this planner is going to review, do some sort of metacognition, like, are we making progress? There's a ledger, a structured ledger, an actual JSON data structure that it updates. So it has things like educated guesses. It has things as the state of progress. Are we stalled? It has a stall counter. Like, have we failed to make progress across n number of tries? And you need to do this because if that is the case, essentially you're taking actions in the real world. What you expect is that it leads to, progress in the problem-solving process. Sometimes it doesn't. And you need to keep track of that. And at that point, the solution might be to sort of reset the state of the entire problem, construct a completely new different problem exploration trajectory, and then explore that again. And at some point, you decide that we really are not making progress and we need to escalate to a user, or we sort of give up at that point. So you need some actual sort of logic that guides, even though you still have an LLM exploring the space, but you do need some type of metacognition logic that ties or drives together all of these. And I'll sort of end a bit on just revisiting some of Kartik's earlier points about like how we can put some structure around the reasoning process of an agentic system, I think the one drawback there is that you really need to know the solution to the problem really, really deeply to construct that space. And so if you want to put the guardrails around what the system can do, you essentially need to solve the problem to understand the problem in real depth. So there's a bit of a trade-off there. So we're also learning about this space. Or maybe Kartik has figured out a way to do this in a generalized form, and he should tell us.
I would like to say that, I have figured it all out, years back. It's just the implementation that's a problem. The agent has figured it out. It's the tooling that's not ready yet. No, I think I will, say that a lot of this theory, I think I saw a question in the chat about, do symbolic AI methods have any role to play in this, right? And I will be kind of the flag bearer of symbolic AI, even if nobody wants to be, right? If you are someone new to this space, right, and you are looking to really make a difference and stand out, right, there is a lot I think we can learn from previous symbolic AI techniques, right? Obviously, sequential decision making, automated planning, but also things like scheduling, replanning. There's a lot of work on human AI interaction, both within the AI community, but also within the HCI community, the human computer interaction community, right? Because I feel like in the coming, I would say years and decades, but we are not operating on those timescales anymore. So I'll say in the coming days and weeks, maybe months,
Literally,
right?
literally.
Yeah. I feel like a lot of the human factor issues, which, to be very honest, we've all not paid a lot of attention to in this mad rush to, build LLM models, build RAG chains, build agentic AI, frameworks and all of that. I think a lot of the human factors issues are going to become very important because we are still in a world where humans want interaction with and oversight of the agentic chains that we build out for them, right? And if I were telling somebody, where to position themselves for the coming weeks and months, right, I would really tell them to focus on how the interaction with these agentic outputs happens, right? Because today that is still not a solved problem. That is in fact the biggest, the rubber meets the road moment, right? We all went through a big revolution like this for RAG, if you remember, right? So for retrieval augmented generation, right? For the longest time, it was very hard to implement that in practice in reality to show organizations that they were getting value out of it, right? Today, we are in that same place with agents and with agentic frameworks and all of that, right? How do you show a paying customer, right? That this, because there was also, I think, some questions about the cost of running these agentic frameworks and multi-agent systems. It's not a non-trivial cost. It costs a lot in token budget, in compute, all of that, in developer time and so on. So how do you realize that value and make it real for your customers? I feel like there's a lot of unexplored work there. And that's where I think symbolic AI techniques from the last 10, 20 years, HCI techniques, I think those will become very useful over there.
I'll add to that accessibility, which I think is super important. The HCI world is like the pioneer, if you will, of accessibility, and LLMs have a huge part to play in the world of accessibility, and more people should go into that field so that we create a more diverse field for ourselves. That I'll add. Lastly, 2 points Victor and Kartik that both pointed out. You said reset the environment, Victor, like reset back to the beginning stages. What we're finding in tool use is there's a lot of cases like if you book, delta.com, you can't just kind of go back a lot of the times. Now you can if you specifically have a tool to do so, right?
Yeah.
But thinking through each of those stages, which kind of gets to the Kartik point of like, are you sure you want to buy this flight? Because especially with the OAuth primitives that we have now, we have the full set of agent user privileges. And so this agent is now empowered to do real things. And so it is important that you have a kind of like a rollback strategy, if you will. That is something that we're actively working on. It's a super curious area that kind of merged two of what y'all had said. Hamza, do you have any final thoughts that we have before we wrap up here?
I just want to say Black Mirror is becoming more real each day.
Oh my God, don't say that. That's the one with the episodic recall where that is the creepiest episode oh my God.
I think I'm just going to say something what Kartik said. You don't need an AI agent for every single problem. You don't. And I think the quicker we understand that, see, how are we building stuff? Or 2 years ago or a year ago, how we were building stuff, we would do a hackathon in an organization and all the developers would sort of build something. That's the wrong way of approaching. You need to have the business owner sitting, having a design session and saying, hey, what is it that we want to solve? And the developers and the tech people will help you understand how AI can solve those problems for you. We've been doing the other way around.
Hammer looking for a nail.
Right, exactly. So we just need to identify, and this is something that we do a lot with our customers, the design sessions, like, what can Gen AI do for you really?
It's like, what are your problems? Work backwards.
Exactly. And is this something that you need? Do you need just a forecasting model, which will wrap it up in a fancy LLM and sell it to you as an AI agent? But the idea is,
We'll have it talk to you. It's just an XGBoost model in front of a wrapper, but it's just XGBoost with an LLM in front of it. I love that.
I love XGBoost and LGPM models.
Hey, nothing will ever beat XGBoost. I'm convinced it's going to die the best classical model of all time. Probably not true, but still, it's undefeated on Kaggle. So I think we're getting kicked off. I just want to say thank you all, and feel free to connect